Okay, so today we are going to be graphing the sine and cosine functions. You may want to pause the video and just take a second to label your axis there with your major angles, and then the highest and the lowest trig value is -1 to 1. So label your axes there, and we can get started. Now, right here, the sine of 0 is 0. So we get that coordinate right there. The sine of pi over 6 is 1/2. The sine of pi over 3 is square root of 3 over 2. Square root of 3 over 2 is approximately 0.87. Okay, so we're looking about right there. And pi over 2 is 1. So this is all using the unit circle over here on the left side. So the sine of pi over 2, remember sine is the y value of the coordinate, so that's how I got pi over 2, 1. And then as I keep going, 2 pi over 3, we're back to square root of 3 over 2, and it's going to come back down. The sine of pi is 0, so we're back to 0, and now they start going negative. So the sine of 3 pi over 2 is -1. So now we're down here. The sine of 5 pi over 3 is a -0.87, or square root of 3 over 2. So it's back to there. This one's there. So you can see these coordinates are giving you this nice little curvature. It's a sinusoidal curve is what we call it. The sine of 2 pi is back to 0. So that curve is going to look something like this. Okay, and that would just keep going there. And the sine of negative pi over 2, so as I come clockwise this way, is -1. So negative pi over 2 is -1. So this will come down here. And then as you can imagine, it's going to go back up that way. Okay? So yesterday you did the Ferris wheel activity, and you learned a little bit about period and amplitude. Period is just the cycle. Is one complete cycle. So right here, if I start at 0 degrees and I get 0, I go up, down, and right there at 2 pi, it starts over again. So it would do another cycle or another period. Okay? So the length of a complete cycle before it starts over for the sine graph is 2 pi. So we say that it has a period of 2 pi. Okay, there's a formula that we use for that. The period equals 2 pi over b. Or you can flip that and we can say that b equals 2 pi over the period. And I'll show you how we'll use that in just a second. Okay, the amplitude, as you learned yesterday, is there's two ways of looking at it. You can either take the absolute max up here, which is 1, and subtract the absolute min, and then divide all that by 2. Or a good way to look at it is the amplitude. If you use this midline that cuts the graph in half, that x-axis, the amplitude is that distance from the midline to the top, or the midline to the bottom. Okay, so the distance there is just 1. So the amplitude of the parent function of sine, just sine theta, is 1. The domain, this graph goes forever, positive and negative infinity. The range goes from -1 to 1. Okay, so notice again the sine graph, this is sine, the sine graph starts at 0, 0. The cosine graph, it's very similar, but the cosine of 0 is 1. The cosine of pi over 2 is 0. The cosine of pi is -1. So this one's going to have a little bit different shape. Well, actually the exact same shape. It just has what I like to call a different starting point. So instead of starting at 0, 0, and at 2 pi we're back at 1. Instead of starting at 0, 0, this graph starts at 0, 1. I guess it's better to say the y-intercept, okay, is at, or the intercept there is at 0, 1, and up here it's at 0, 0. Okay, so this graph comes back down, and as you can imagine, it just continues. So if I start here at 1 and I go through a complete cycle, I'm back here at 1, and it just starts over, and it does it again, and does it again, and does it again, an infinite number of times. So again, for this one, the period is also 2 pi before it completes its cycle. The amplitude is also 1. It's that distance from the midline up to the max. The domain is also all real numbers. And the range is also -1 to 1. Now flip this over and we can look at some of these graphs. Here you've got a sine graph. The amplitude is now 3. Okay, so that's your vertical stretch. The period goes from pi, it completes a cycle at 3 pi, so the period is still 2 pi. Okay, so earlier I told you that period equals 2 pi over b. So you can also say that b equals 2 pi over period. So in this case, 2 pi over 2 pi, my b would be 1. So that tells us that there's no horizontal stretch or shrink with this graph. As long as the period is 2 pi, your b will always be 1. Okay, but my amplitude is now 3, so I do have a little bit of a stretch. So we'll say that 3 times sine. Now, think of it as if the starting point was at 0, now the starting point's at pi, so this graph moved right pi. Notice I didn't put a b there because my b is 1. Now, there's always going to be different answers that you can get. There's a lot of different answers, but I tried to darken the graph I wanted you to figure out the translations that way. Okay, let's look at another sine one here. This one goes from -pi to 0. Okay, so there's a horizontal shrink there. So if I say that b equals 2 pi, this period is pi. The pi's crossed out, so I get b equals 2. My amplitude is still 1. Now we can look at this as a reflection over the y, if you want to look at it that way. Or you can say it reflected down, because this part of the graph should go up, but it goes down instead, and it moved left pi. So, you know, like I said before, you can get different answers. So we can say sine, the amplitude is 1, so there's no vertical stretch or shrink. If we look at it like an a horizontal flip, then we can say sine of negative 2x. Or we can say that the graph flipped over the x-axis, like that. You have your horizontal shrink, and then it moved left pi. You know, so either one of those will work for that graph right there. Let's look at a cosine real quick. If I have a midline going through here at 1, I have an amplitude of 1. My period starts at 0, starts at 0 and goes to 8 pi. So we can say that b equals 2 pi over 8 pi. So b is 1/4. So this graph, we can say that it's cosine 1/4 x, and then you need that plus 1 because, see, this midline was on the x-axis, but now it's on 1. Okay? So I want you to finish up the rest of this worksheet right here, and then you also have a few more problems that, that are up on the board. Okay? Enjoy.